Hey everybody, let's officially get going here, huh? Yeah, we're gonna wrap up the third quarter, and to do that, we just got to finish up chapter three. But I thought it'd be a pretty good idea, and it'd be definitely worth the time to do a little review of everything that we had already covered in chapter three before the big school shutdown. So if you, I attached this file, this little collection of problems, in Google Classroom. So if you happen to have a printer, then and if that's what your routine is going to be, print this out and kind of follow along with me, or maybe just get some separate paper. But I do want you following along with me. All right. And if you want to pause the video really quick before I show each problem and you can try it yourself first, that might be even better. So let's see what we have already covered in chapter 3. Take a little quick trip down memory lane. In other words, now, where were we? Well, at the start of our chapter 3, we were solving equations like this, where we had to figure out what to do if we had an x variable on both sides, and we had to move them together on one side. Like we only want x on one side. So our routine was to move the smaller x to the other side. So in this case, we're going to subtract 4x from both sides. We're going to move that to the other side. And now over here, 6x minus 4x is 2x. And we still have that minus 4 over there on the left side. And now the right side is just the positive 10. And now we can get this x all by itself by moving that negative 4 out of there, by canceling out that minus 4. And we do that by adding 4. So we add 4 to both sides of the equal sign. So now that's out of there. And x is a little bit closer to being all by itself. And then over here, 10 plus 4 is 14. Now the final thing to get this x all alone is we got to get rid of that 2. Now again, remember, big reminder, this says 2 times x. How do we get rid of this 2? Like, how do we cancel out multiplying by 2? Again, this is 2 times x. Well, the opposite of timesing is dividing. So we divide by 2 to get it out of there. And so my final answer, since 14 divided by 2 is 7, my final answer is 7. Now we can kind of speed up the process a little bit. That negative 3x is smaller. So we do the opposite. How do we get rid of a negative 3x? How do we move a negative 3x? We add 3x to both sides. So that's going to become a 5x over there with the plus 5. And now we can get x all by itself and then divide both sides by 5 and get x equals 1. And hey, we're going to do a few more, okay? That negative 2x, remember we have x's on both sides, that negative 2x is the smaller one, so I'm going to do that to get rid of that from over there. Now the left side is just 5. 2x plus 2x is 4x with the minus 7, and now I got to get that x all by itself, so I add 7 to both sides. And I get 3 equals x, which is the same, of course, as saying x equals 3. This next problem, the negative 5x is smaller. Now, I'm going to pause really quick here just to kind of remind you of something. You don't have to move the smaller x. Like if you want to, you can move this x term over to the right side. If you want to gather the x terms over on the right side of the equal sign, that's totally fine, but I guess we were sticking to a policy of moving the smaller of the two x terms to the other side. So here we're moving and we're gathering the x's over here on the left. Negative 2 plus 5 is positive 3, so it's positive 3x, and we have this plus 11 term also, and then over here there's still a negative 4. Now we move into the part where we're getting x all by itself, and negative 4 minus 11 is negative 15. And now we divide both sides by 3, and our final answer is negative 5. Okay. Just had to move some clutter around here. Alright, now when we have a bubble, the first thing we need to do is distribute to clear the bubble. So we distribute the 2. That's 2 times x, which is 2x, and then 2 times positive 7, which is positive 14. And then the other side gets brought down, and now we can move on with our business. Let's move that away from that side. So now over here, 2x minus x. Remember, this is like 1x minus 1x. So 2x minus 1x is 1x, which again is the same as just x. But let's, and then we got to get, and really that's just x. We got to get it by itself now. Subtracting 14, and 10 minus 14 is negative 4. Number 6. Okay, last one from this quick little recap. See now, just like in number 5, where if there's parentheses, that's like the first thing you pretty much always want to do is clear the parentheses, clear the bubble by distributing. But there's other things that can take priority at first as well, like if there's like terms that are already on the same side as each other, you just combine them. You know, like over here, this 4x and 5x, they're already together on the same side, so they just combine to be 9x. Okay, now we can get on with business. Like we got to get the x's on the same side, only on one side, so let's move that. And so 9x minus 3x, that's 6x. Bring everything down nice and tidy, right? And now we can work on getting x all by itself by doing the opposite of things that are crowding it. And so now it's just 6x on that side, and the right side has become 18. And now we divide both sides by 6. And the final answer there should be 3. Moving on. This was something else. Okay, remember problems like this? Right? This was something else in chapter 3, but guess what? I'm not going to worry about this, like on a quiz or a test, okay? But, so this is something you may do right now. You don't have to do it, but you may do it, okay, if you want to. I'm going to do it right now really quick, just to kind of, in case you did it. But if you don't care, then skip to, you know, this part. But you know, here I go. This is something you might want to do. So remember, this is where you could like either guess and check, and just make sure you come up with like a number of dimes and a number of quarters that makes all this make sense. But what you could do is the whole like setting up of an equation, where you do like 0.25 times the number of quarters, like the mystery number of quarters, which we're just going to call Q, plus 0.10 times the mystery number of dimes, and that's how you're going to total up your $5.10. Can't solve this equation since there's two different letters, but since we know that there's 2 more dimes than there are quarters, okay, that means that the Q variable, right, instead of just saying Q, you could say number of dimes plus 2. Okay, actually that's backwards, I think. It's a little embarrassing, but I knew something was weird about that. You know, it's tough when I'm on a roll. I'm just flying by the seat of my pants here a little bit, but there's two more dimes than there are quarters. So instead of saying dimes, you know, couldn't you just say the number of quarters plus 2? Like, we don't, instead of saying D, we could just say Q plus 2. Since if you do quarters plus 2, that's literally the same as dimes. I mean, right? Quarters plus 2, and that's dimes. So over here, we could kind of like replace the D variable with Q plus 2. All right, and now you can solve this for Q. Now that there's only a Q in your equation, now you can solve for Q. First by distributing, of course. 0.10 times 2 is 0.2, or 0.20. And now we can combine these like terms and get 0.35 Q. And we can move that to the other side since we just ultimately we want to get Q by itself. So when we subtract that over, we end up with 4.9. And if we divide to get Q all by itself, 4.9 divided by 0.35, we get 14. So Q equals 14 quarters. And if there's 14 quarters, that means that there's 16 dimes. Okay, anyway, moving on with mandatory business. Remember, these pictures, fill in the blanks with the correct information. These pictures are related, you know, but for now, for the stuff we're doing, or that we were doing and we are doing and continuing to be doing in Chapter 3, we're more concerned about how a false statement makes you give a final answer of 0 solutions. Yes, you can use this picture to help you remember, but really for right now, this is like more something in your future. For right now, 0 solutions to us means that it was a false statement. And if we get x equals some number, that means there was 1 solution. And if we get a true statement, that means that there are infinitely many solutions. And again, the pictures are related and they can help you remember if you want, but you know, and so let's see that in action. First we have to clear the bubble by distributing, and we have to multiply the 6 to both those terms, 6 times x as well as 6 times positive 7. Now watch what happens when we go to get the x's together, only on one side. Not only does it cancel out from the right side, it also cancels out from the left. That's our plot twist. That's like, whoa, what? Like, my x is totally gone. And what remains is a positive 42 on the left side and a positive 7 on the right side, and no more x's at all, you know. Now, this statement is either going to be true or false, and it's false. So that means that there's no solution. Over here, when we distribute, and looks like we got to distribute on both sides, we get 5x minus 10 over here and 2x plus 2 over here. And now when we proceed to solve this, okay, so this time the x's didn't go away entirely. I end up with a 3x over here with the minus 10 and over here. And so we keep this rocking and we get 3x equals 12, and therefore x equals 4. But the bottom line for this problem is that this is the answer. This is the only answer that there was, and there was one solution here, okay? in this problem, there was some terms to combine over here, and now when we go to get the x's only on one side, they totally go away, and what you're left with is 4 equals 4, which is true. 4 does equal 4. And so the answer is that there's infinitely many answers. There's some combining again. 4x and 3x makes 7x. The right side is the same, and so we want to get the x's, and they totally go away again. And the only thing that's left is 8 equals 12, which is false. So no solution. All right. Then at the way end of class, like before the big shutdown, we were talking about domain and range. So this, I believe, is now section 3.3. To be more specific, like 3.3a. Okay, this was like this section. All right. 3.2 would have been like when equations end up with only like no solutions, or maybe one solution still, or infinitely many solutions. So remember, domain is just all the x values, and range is all of the y values. So the domain here would just be all the x's. Remember, all these go x, comma, y, x, y, x, y, x, y, x, y, x, y, x, y. So all the domain values, all the x's, would be 1, -2, -3, -1, throw in a 0, throw in a 2, and throw in a 3. And the range is all the y's, all the y values, 2, 4, 2 again, don't need to write it again. I don't need to write that again. So -4, 5, 3, and then 3 again, which I don't need to write down a second time. Is the relation a function? Okay. What determines that, if you remember, is if there are any repeat x values. A function is not allowed to have any repeat x values. So since there was no repeat x values here, this is a function. You know, if it does not have any repeat x values, it is a function. Number 16 is even easier. They literally have like broken this up into 2 columns. You know, sorry, I kind of abused the word literally there. It's not literally broken up. It's broken up into 2. Like the x's and the y's are totally separate from each other. So the domain is just all the x's, right? 1, -2, +3, 5. 1 again, which means this is not a function. And we also have a 4. Okay, and the range is -4. It's just all the y's. That's it. As long as you remember what domain and range mean, these are like the easiest questions ever. Number 17, you know what? Another casualty. Not going to worry about it, okay? But if you want to do this anyway, I mean, skip over this part of the video if you want to, but if you want to give this a go, hey, respect. The domain, so all the x's are over here and all the y's are over there. So, you know, the domain would have just been like -3, 0, 2, 3, and 4. And the range would have been -4, -2, -1, 0, 1, and 5. And is this relation a function? No. Because if you look here, this x value is mapping, that's the word mapping, it's mapping to the -1 and the 5. So you could have like written this as 3 comma negative 1, and there would also been a 3 comma 5, which means there are repeat x values. We double dipped on the 3, not allowed. All right, once again, number 18. Okay, I'm going to start with 18C. Is the relation a function? This is a yes. Because once again, there's no, if you look at all the points that could be on this graph, there's going to be no repeat x values. A very easy way to determine this, like a shortcut, a trick, is what's called the vertical line test. Okay, which means if you can draw a vertical line anywhere on your graph, okay, if that vertical line only can hit the graph once, passes the test. So if you can draw any vertical lines that would hit the graph twice, then it would be a fail. Like here's that example on the next one. You know, remember, if you can draw a vertical line that would hit the graph in more than one spot, like look, it hits the graph there, it hits the graph there. So that vertical line hits the graph twice. That's why this one is a no. Right? So 18C is a yes based on the vertical line test. Vertical lines would only hit that graph one time, no matter where you drew the vertical line. But 19C is a no. Now, these other guys, casualties. Not going to worry about it, but if you want to give those a try, you know, hey, that's something you may do. You have my permission, or you can skip ahead in the video, okay? So here I go. The answer, so again, I'm kind of assuming you've paused the video and you've already thought about what the domain is and the range and stuff. So here I go. Spoiler alert. Spoiler alert. The domain on this guy is 1 to positive infinity. In other words, all x values greater than or equal to 1. That's another way you could have written the answer. And the range is from 0 to infinity. In other words, all y values greater than or equal to 0. For this one's domain, this would have been negative infinity to 1. All right? In other words, all x is less than or equal to 1. The range of this relation is basically all real numbers from negative infinity to positive infinity. All right? Now number 20, guess what? Casualties. So keep moving on. But if you want to pause the video again and give this one a try, then hey, knock yourself out, because I'm going to reveal the answers here in a couple seconds. Spoiler alert, last chance to pause. Okay, I warned you. So here's what the domain would be. This domain would actually be negative infinity to positive infinity. You can plug in whatever x value you want into this equation. There's no reason you couldn't square any number you want. So there's no restrictions on what x values or what I could let x equal. But the range, the y values can only be as low as -5, but there is no limit on how high you can make your y values. So your range is from -5 to positive infinity. And is this equation representing a function? You know it. Last page! Whoa! Now, hey, okay. Before I get into this last page, let's just catch our breath. You know, let's let's get a grip on the big picture and on, like, let's get some perspective, as I like to say. This is where, we basically had school get shut down. I don't even remember for sure how much we got into looking at a table, right? Looking at a table and figuring out what the equation might be. I don't know. So this last page, this is actually what you're going to have, so I think I'm calling this video, and following along with this video, I'm calling it assignment 1, or like your Monday assignment. I don't know, however you're pacing yourself. So this video is like literally assignment 1. Assignments number 2 and 3, at least my plan. Assignment 2 and assignment 3 are going to be assignments, like little mini homework assignments, based on this last page I'm showing you. Okay? So 21, 22, and 23. If you are given a table, can you come up with like the pattern? Can you find a pattern, that fits how these x values and y values relate to each other? Okay? What's the equation? Let me get a quick little sip of water. So number 21, what's the pattern here? What would you do to these x values to make them equal all these matching or corresponding y values? Like, how do you make a -3 into a -6? What do you do to the -2 to make it into a -4? What do you do to -1 to make it into a -2? And if you do that to a 0, it stays 0. And if you do it to 1, it becomes a 2. And if you do it to 2, it becomes a 4. If you do it to 3, it becomes a 6. Like, what is the math that is making this happen? And it turns out that we are multiplying the x values by 2. So if you do 2 times x, it's going to equal y. So this equation is the answer. The y is going to equal 2 times the x. So y equals 2x. In number 22, -3 becomes a 1, and -2 becomes a 2. Look, I don't want to confuse you. I don't want to get too long-winded, too late, but I mean, if you look at I guess if you look down here, this might be, a 2 can become a 6 by multiplying it by 3. If you multiply this x by 3, it becomes that. But does that pattern hold true for, if you multiply 3 to that, does it become a 7? If you multiply that by 3, multiply that by 3, multiply that by, no. So the pattern is not, even though it works for this 2, 6, it doesn't work for anything else. So the pattern is not multiplying by 3. But another way a 2 can become a 6 is adding 4 to it. And so does adding 4 hold true? It does. So that makes your answer, you take x plus 4, and it's going to equal the y. Over here, it turns out that, I'm going to write this up here just for a second. It turns out that if you do -1 times the x values, it creates the corresponding y value. Now, you don't need to literally have the 1 there. You really just need to say y equals -x. That's the same thing. Y equals -1x, y equals x. And now, all right, final stretch here. We're going to complete the table and even draw the graph. Now I'm not going to X out all these graphs, okay? I'm not actually going to do it here, okay? Because that'll just get in my way. But you could think of it as I might as well X out these graphs when it comes to your, well, actually, I take that back. On your test, on your test, I'm not going to need you to graph the stuff, but on your homework, I am. So never mind. Let's do this. Let's consider this a must do, not a may do. Even though on your quiz, it's not going to be there. On your homework, it will. So here's what we do. We look at each equation and how it goes. Y equals -2 times x plus 1. And we have all these different x values, okay? And we have to figure out what value of y goes along with each x value here. So here's what we do. If that x was instead just a -3, what would happen? You know, if this had said -2 times -3 plus 1, -2 times -3 is 6, plus 1 is 7. So if x was actually a -3, then y would literally equal -2 times -3, which is 6, plus 1, which is 7. If you plug in -2, you get 5. If you plug in -1, you get 3. If you plug in 0, -2 times 0 is 0, plus 1 is 1. Remember, y equals whatever all this comes out to equal. If you plug in 1, you get -1, and then -3, and then -5. So graphing this, every single pair like this, these are like literally coordinates, like ordered pairs for points. So -3, 7, oh boy, right there. -3, 7, -2, 5, -1, 3, 0, 1, 1, -1, 2, -3. I hope I don't make a stupid mistake here. 3, Alright, so it turns out that this equation just makes this downhill line. Okay? Now 25. Y equals x squared and then -3. If you take your x and square it and subtract 3, that's going to equal y. Let's start here. If you plug in 3, if that was actually 3 squared minus 3, 3 squared is 9, and then -3 is 6. Okay, so 3, 6 should be like right there. Okay. If you plug in 2, you get 1. If you plug in 1, you get -2. If you plug in 0, 0 squared is 0, -3 is -3. Now, okay, here we go. Pay attention. If you plug in 1, all right? If you plug in 1, or sorry, what did I say? If you plug in -1, right? Be very, very, very careful here. Because if you have a calculator at home, I hope you do, and if you just type it in as -1 squared, or (2), whatever, -3, that's going to give you the wrong answer. Okay? That would be wrong on your calculator. If you're typing this into your calculator, you need to square the entire -1. You have to tell the calculator that not just the 1 is squared, the entire -1 is squared. You would need those parentheses typing it into your calculator all at once, okay? Because -1, the whole thing of -1 being squared, is +1, and then when you -3, you get -2. So -1 squared is +1, and then 1 minus 3 is -2. Okay, -2 squared, that's +4, and then -3 is 1, and then 6. So -3, 6 should be there. -2, 1 should be there. 0, -3. Well, I actually forgot one. -1, -2 is right there. Where did I leave off? So I need to do 1, -2. I need to do 2, 1. Okay, so here we go. So there are those dots, and this ends up being a U shape. That is a U shape. 26, there's a similarity here to number 25. You know what I mean? Because when you type in, I guess this is supposed to be a 3 that got chopped off on the printer. When you plug in 3 for x, this says absolute value. The absolute value of 3 is just 3. Plus 2 is 5. 4, 3. The absolute value of 0 is just 0. Plus 2 is 2. Sorry. Now, but when you plug in negative 1, the absolute value of negative 1 is positive 1. And then plus 2 is 3. Absolute value of negative 2 is 2, and then you add 2, and you get 4. And then the absolute value of negative 3 is positive 3. Plus 2 is 5. So when you graph all of these, negative 3 comma 5, negative 2 comma 4, negative 1 comma 3, 0 comma 2, 1 comma 3, 2 comma 4, and 3 comma 5. And so look at those dots. This is a V graph. Now, as I get a sip of water here before the final problem, you know, I'm putting arrows on these graphs because these graphs keep going on forever. You know, I only put so many values in my table. You know, you don't plugging in negative 3, negative 2, negative 1, 0, 1, 2, and 3. They're not the only x values you could plug in. You could plug in 10 for x. You can plug in negative 50 for x, you know. So that's why these graphs just keep, heck, you could plug in like 2.5, you know, for x. You can plug in 1.7. There's a point somewhere on this graph that is 1.7 comma something. In fact, it's 1.7 comma 3.7. 1.7, it's like right there or something. You know what I mean? Anyway, number 27. Square root. So this means big old square root. So looks like we gotta do the x plus 1 and then take the square root. Because see how this square root is like over this whole entire x plus 1? Alright. So if you plug in 3, again, there's a reason I'm starting at the positive 3 and we're going to work our way there. So if you replace the x with 3, and this becomes the square root of 3 plus 1. First of all, 3 plus 1 is 4. But then you got to take the square root of 4. Okay? The square root of 4, in case you forgot this or never learned this, that's solid. Square root of a number means the number that can be multiplied by itself to equal 4. So the square root of 4 is whatever number can be multiplied by itself to equal 4. So the square root of 4, because again this 3 makes it 4 under there, the square root of 4 is 2. Okay? Because 2 times 2 is 4. When you throw a 2 in there, I think I know this answer, but I'm just going to double check. 2 plus 1 is 3. The square root of 3 is actually approximately 1.7. Approximately 1.7. 1.7 times 1.7 is about 3. If you plug in 1, okay, you end up with the square root of 2, which is approximately 1.4. Let me just double check that. Yep. If you plug in 0, you end up with the square root of 1, which is just 1, because 1 times 1 is 1. All right. If you plug in negative 1 plus 1, that makes it the square root of 0, which is in fact 0, because 0 times 0 is 0. 0 times itself is 0. Okay. Now, ready? If you plug in -2 in for x, -2 plus 1 is -1. You would end up with the square root of -1, which, in a way, doesn't exist. Okay? For now, we'll say that it does not exist. You cannot take the square root of -1. Okay? So there is no answer for that. There isn't one, you know? And there's not going to be a point that has -2 as the x coordinate. There just won't be, okay? Same with this -3. You know, when you plug in a -3 for x, you end up with the square root of -2. Doesn't have an answer, so nope, doesn't apply, you know? So on our graph, when we do 3, 2, which is right there, 2 and then about 1.7 right there or something, and then 1, 1.4 is right about there or something. Gotta estimate that sucker. And then we got 0, 1, which is right there. And then -1, 0, which is right there. And since we can't even plug in any of these other negative x values, then this graph just kind of starts right there, like out of thin air. You know, it goes from here and then it curls up and to the right forever. Okay? Whew, sorry, that might have been one of the longest, maybe the longest video of this entire virtual learning experience that we're going to have together over the next 6 weeks or so. So sorry about that. The most other videos are going to be much shorter.